Number 25. Use the graph of f of x equals 2 to the x shown in figure 31 to sketch a graph of the transformation of f of x. So we have a picture of the graph here. Figure 31. So we have this transformation h of x is equal to 2 to the x minus 3. So let's let y equal 2 to the x minus 3. And we can move the negative 3 to this side, so we have y plus 3 or y minus negative 3 equals 2 to the x. Alright? So what this is going to do is shift the original graph down 3 units. You know it's going to go down because this is next to the y. Think y-axis as being vertical, up and down. And then the negative 3 is a downshift. If it were positive 3, it would be an upshift. Remember, it's always written as y minus something. And that something tells you which way to go. Alright? So what you can do to graph this is take a couple of representative points on the original graph. If you look at figure 31 of f of x, you can take, for example, the point 0, 1. And how about you could take 1, 2, or there's one a little bit farther away. How about doing that one? 2, 4. Alright. So if you do it by points like this, it'll help you to graph it more easily. So there's 0, 1 there. And then there's 2, 4 right at the tip of the arrow. So let's see what happens to these. You just add negative 3 to the y coordinates here and here. Alright? So that changes to 0 and 1 minus 3, or 1 plus negative 3. This changes to 2, 4 minus 3, or we've got 0, negative 2, and we have 2, 1. So those are 2 new points on the transformed graph, and let's see if that bears out with the answer. I'm just going to refer you to the answer in the book. So if we look at, we should have the point 0, negative 2 on there. 0, negative 2, there it is. And we should have the point 2, 1. 2, 1 right there. Okay, so you can plot those 2 points and then use those as guidelines when you draw the rest of the graph. You can pick other points as well and do the same thing. Since this is near the y, next to the y, this number here, you just add that to all the y coordinates on the original graph, and it's pretty simple. If, let's say you had 2 to the x, but the minus 3 is up there with the x. Well, this is x minus, well, let me make that a minus a negative 3, since just to keep it consistent with the what we've just done. So what if it were 2 to the x plus 3, for example, or 2 to the x minus negative 3? Alright. Well, that would be a shift to the left, since think left or right, since it's next to the x variable. It would be a shift to the left because it's negative. If it were positive, if it were 2 to the x minus 3, it would be a shift to the right. But this is a shift to the left, so what you would do to get the transformation to get it easily is just add -3 to all the x coordinates on the original graph, just like we did here with the y coordinates. So 0, 1 would become -3, 1, and 2, 4 would become -1, 4. All right. If you don't believe it, graph that on your graphing calculator and see if it bears out what I just said. All right. So it's really when you're doing it this way, it doesn't become too difficult to transform these graphs. Okay. Number 27. For the following exercises, sketch a graph of the function as a transformation of the graph of one of the toolkit functions. So we have f of t equals t plus 1 quantity squared minus 3. Alright, so let's let y equal f of t. Okay, so y then equals t plus 1 quantity squared minus 3. And I'm going to move this -3 to the other side, so subtracting that from both sides, I've got y minus -3, or same as y plus 3, equals t, write that as t minus a -1 instead of plus 1, and then squared. Alright, so basically what we have here is a parabola, y equals t squared, but it's been, this tells you here, think the t-axis this time instead of the x-axis. Alright, so it's going to be a left shift 1 unit, and here we're going to have a shift down 3 units because it's a -3. Alright, remember the format, y minus and x minus, or t minus in this case. Okay, so y equals t squared will have the vertex at 0, 0, but on this one you're going to add -1 to the x coordinate, so that becomes 0 plus -1, or 0 minus 1 is -1, and you're going to add a -3 to the y coordinate here. 0 minus 3 is -3. So our new vertex is -1, -3. Alright? And that's borne out in the solution in the back of the book, as you can see there. Oops. And they labeled that as the x-axis by mistake. Okay, so that should be the t-axis, because that's what they gave us in this problem. So there's your vertex. -1, -3, as we thought. Okay, number 29. K of x equals the quantity x minus 2 cubed minus 1. So let's let y equal k of x. Alright, so y is equal to the quantity x minus 2 cubed minus 1. Alright, move the minus 1 to the left side here. Y minus -1 equals x minus 2 in parentheses cubed. So now we have it in the usual format, y minus, x minus. y minus some number, x minus some number. All right. This number here is a positive 2, x minus positive 2. So that tells you that there's going to be a shift to the right 2 units. Basically what you have is y equals x cubed. All right. So you're going to shift y equals x cubed 2 units to the right. And this will tell you it goes down 1 unit down. So it's right 2 units, down 1 unit. And that again is borne out by the answer in the book, as you can see right there. Okay, number 31. Tabular representations, or rather tables, for the functions f, g, and h are given below. Write g of x and h of x as transformations of f of x. So here's the tables, the tabular representation. Right there, as you can see. Okay, let's first consider g of x. Now, if you look at the function values, that is the outputs, so compare that to f of x. Take a look here. -2, -2, same thing, -1, -1, -3, -3, and so on, right? The outputs are the same, but the inputs are different, aren't they? The inputs are different. So, the inputs have shifted, so that tells you that the graph has shifted right 1 unit relative to the inputs. Okay, so if you add, in other words, if you add 1 unit to each of these x values here, the inputs, add 1 to -2, you get -1, and so on. You just add 1 to each of these inputs. Alright, you've got the same y values, but they belong to different inputs that have been shifted. Okay, so what this is a shift to the right 1 unit. So g of x then is equal to f of, now we're shifting f right 1 unit basically, so x minus 1. Alright, shifting it 1 unit to the right. So you put that next to the x. Again, this has the same effect right here as adding 1 to each of the x values in f of x, the inputs here. So you just add 1 to each of these x values, the inputs, and you get these new points, right? So that gives you that shift to the right 1 unit. We've been talking about doing this in the past several or few problems that we've done. All right, just talk about taking representative points and adding to the x or y coordinates depending on where the shift is. So it's the same principle here. Okay, if that isn't clear to you, maybe you haven't looked at the other solutions that we've done before this one, so that's where I bring it up. So you might want to go back and take a look at those. All right. How about h of x? So if you look at h of x, the inputs are the same as f of x, right? So take a look at h of x. The x values are the same, the inputs, but the y values have changed. Basically, you're adding 1 to each of these y values in f of x, or the outputs. You're adding 1 to the outputs. Okay, so In other words, if you add 1 to each of the y coordinates in the original function, that's like shifting it up 1 unit, shifting f of x up 1 unit. So h of x is equal to f of x plus 1, or if you wrote it as y equals f of x, then what h of x is y minus 1 equals f of x. Alright, you can move this minus 1 over to that side and you'll get this right here, h of x. So this is moving it up 1 unit, and you would add 1 to each of the y coordinates in the original f of x to get that shift, alright, which is what we saw in the table. Okay, number 33. For the following exercises, write an equation for each graft function by using transformations of the graphs of one of the Toolkit functions. So here's the figure, the graph for this problem, right there. Looks like the absolute value function, which has been shifted around, huh? Which is, yeah, that's what it is. It's the absolute value function. Alright, it's got that V shape to it. So if you look, what's going on? Looks like we have a shift to the right and then a shift down. You take the vertex of the absolute value function, which is at 0, 0, and you shift it right. How many? Looks like 3 units, and down 2 units. Okay, so shift to the right 3 and down 2. So what we have here then, this is called f of x here in your graph. So f of x is shift 3, so to the right. So that would be absolute value of x minus 3, and down 2 minus 2. Alright, so written our usual way, that would be y minus negative 2 equals absolute value of x minus 3. That's the way I like to do it. There's your downshift and there's your right shift. Alright, so you can move that to the other side and get this, which is in your book's answer. Number 35. Take a look at the graph. That looks like the square root function, y equals square root of x. Alright, and it's shifted to the left 3 units. Remember, it starts at 0, 0, so it's left 3 and down 1, as you can see. Left 3, take 0, 0, go left 3, down 1. And that's where the graph starts. Right there. Alright, so that'll tell you the formula. So we take so left 3 is x minus negative 3, and down 1. So basically it's like this: y minus negative 1 equals square root of x minus negative 3. Alright, and you can move that to that side. So that tells you a downshift of 1 unit and a left shift of 3 units. So you could write that as y equals square root of x plus 3, and then minus 1, or change that to f of x, and that's in exact agreement with your book's answer. Alright. Number 37. The graph right there. Now that looks like y equals x squared. but it's been shifted to the right. How many? 2 units. Usually the vertex is at 0, 0. Well, it always is for y equals x squared. Not usually, always. But this one has been shifted to the right 2 units. Okay, and that's the only thing that looks like is happening. So this is basically y to the y equals x squared shifted right 2 units. So we can write the new graph as y, or rather f of x equals x minus 2 quantity squared. Okay, x minus something, that something is a positive 2, so that's your right shift, 2 units. Number 39. Well, there's your absolute value shape, the V. So it looks like it's been shifted left 3, starts at 0, 0, but this shifts left 3 units, down 2 units, left 3, down 2. So left 3, down 2. So we could write down 2 would be y minus negative 2, and then absolute value of x minus left 3, so that's negative 3, like that, absolute value function. Or you can change that to y equals absolute value of x plus 3, and then minus 2 at the end. And you can write f of x instead of y. F of x is absolute value of x plus 3 and then minus 2. Alright? Number 41. Use the graph of a transformation of the square root function to find a formula for the function. So here's the graph. Looks like this, yeah, it is a square root function, yeah, but it's been reflected. I don't see any stretching or anything like that going on, because it looks like 4, 2 became 4, negative 2. Is that right on there? Pretty close anyway. 4, 2 becomes 4, negative 2. It's a little bit off on this picture. That's what I mean about these printing, little printing errors in the graphs. You know, there's a little bit of play there going on, but you can assume that's 4, negative 2 there. All right. So it's basically y equals square root of x reflected across the x-axis. Now the reflection, in other words, is going like this. It was up here and it goes down here, right? It flips across the x-axis, or in the same direction as the y-axis. The flip goes in the same direction as the y-axis. So you would write y over a negative 1 equals the square root of x. That's what this negative 1 under the y will do. It'll cause a flip going in the same direction as the y-axis, like this. Alright? That's why I put it under the y. If it were going like this, in the same direction as the x-axis across the y-axis, then I would put that minus 1 under the x in the radical there. Alright? But that's not what's going on here. So you can move the negative 1 to that side, multiply both sides by negative 1, so you get y equals negative 1 square root of x, or just negative square root of x. Alright? Or write that as f of x equals negative square root of x. So this is basically a graph of the negative square roots of x. If you wanted to show both positive and negative square roots, you could write g of x equals plus or minus the square root of x. And you'd have basically what looks like a parabola laying on its side like this. That would be g of x, but that's not what we have, but that's a little bonus there I'm throwing in for you, okay? All right. Number 43. For the following exercises, use the graphs of the transform toolkit functions to write a formula for each of the resulting functions. All right, so here's 43's graph right there. So this looks like y equals x squared, the parabola, but it's open downward and there's some shifting going on. All right, so basically you reflected y equals x squared across the x-axis. That'll cause it to open downward. All right, and it's shifted up 2 units and to the left 1 unit. So you reflect, then you shift. All right, shift up 2 and to the left 1, up 2 and to the left 1. So it was, the vertex was there. When you shift it, or rather reflect it, it's going to open down and the vertex will still be at the origin, but then you shift it up 2 and then left 1. All right, so how do you show that? Well, it's up 2, so it's y minus 2, and then the reflection is across the x-axis, so it's in the same direction as the y-axis, like this. So you put a negative 1 under that part right there, all of this. All right, put it under all of that, next to near the y there, and then it's shifted also to the left 1 unit, so that's shown here like this. So it's basically y equals x squared, shift left 1 unit, so that's next to the x there, and that's the upshift 2 units. All right, so you can multiply both sides by negative 1, simplify this a little bit, and that becomes x plus 1. Move the 2 to the other side, so you get y equals negative x plus 1 quantity squared plus 2. Alright, so that would be writing it in a simplified form, or to make this absolutely correct, we've got f of x here instead of y. Alright, so there you go. Number 45. Take a look at the graph. Right there, all right. So it looks like the square root function, which usually goes that way, right? But looks like we have a reflection going on across the y-axis and then a shift up 1 unit. Starts at 0, 0, y equals square root of x, but this is up 1 here, and there's been a reflection across the y-axis. All right, so our reflection is going this way. All right, the flip's going that way. So that tells you to put that negative 1 under the x. So it's y minus 1, that's your upshift by 1 unit right there, equals, and then you take the square root, and then x divided by negative 1. Alright, so that tells you there's a reflection going this way. Alright, in the same direction as the x-axis or across the y-axis. Alright, so simplifying this a little, move that to that side. You've got y equals square root of negative x and then plus 1. Or to agree with our book's answer, we've got f of x equals square root of negative x plus 1. Okay?